In this video, I'm going to talk about a use case related to using Amazon CloudWatch for logging. Uh, Before that, let me explain the problem statement a bit here. So we have an EC2 instance, and on that we have a web application running. The web application is generating some logs, which it is storing in some directory on the EC2 instance. Then we are shipping the logs, which are being saved in the directory to CloudWatch. And then we are going to run some queries on some conditions on those logs and send alerts out to the developer. The idea here is that we want to store all the logs that our application generates and use them for alerting or further analysis. Now, one way to solve this problem without CloudWatch is Elasticsearch. But that is kind of expensive since we have to create our own Elasticsearch cluster and maintain it. Well, AWS offers that as well as a service, but well, that's not free, and running Elasticsearch is expensive. So basically, this solution is very similar to the previous one, just that instead of shipping logs to CloudWatch, we are shipping that to Elasticsearch. And there's one more piece here, which was CloudWatch sends alerts directly to the developer, whereas in this use case, we have to write our own script or some another service which kind of queries Elasticsearch, runs the condition on which to alert, and then alerts the developer. Also, there's one important thing to consider here, that you might be just starting up with your product. You might not have like a very high volume product which is getting a lot of traffic, and you have to kind of ship logs for analyzing. You want to store them for a month or two, and you don't want to set up Elasticsearch, and it's going to be expensive. Also, you don't know anything about Elasticsearch and how to work with it, so that's an overkill. By the way, Elasticsearch is awesome, so nothing against it. All right, before we move any further, let me give you guys a quick introduction to CloudWatch. CloudWatch is an amazing service offered by Amazon, basically AWS, which lets you ship events, logs, and custom data from all these places. By the way, these places automatically emit events and logs, which can go to CloudWatch directly. Whereas you can configure what your EC2 instance kind of emits. Pretty much any service which you have on AWS sends some sort of data to CloudWatch, be it metric or logs. I'm going to make a different video on CloudWatch altogether, which is going to explain a lot of things, all of this in detail basically. But for now, the idea that CloudWatch is a service where all other services kind of emit logs, events, and metrics should be good. Another major add-on is that CloudWatch can then compile all of the data that it receives, and you can write complex queries which kind of run some condition, and based on those conditions, they can send you alerts. Now, why alerts? I hopefully think that you all know why we need alerts. If not, I'm going to make another video on it where I'm going to talk about why in a system like this, which has a bunch of moving components, why alerting is important, and before that, why even collecting metrics and logs is important. All right, before we move any further, let me go ahead and create the AWS instances and the infra required for this test. I have Terraform code written, which is going to take care of creating the infra on AWS. I'm not going to go through the manual way. Let me just briefly describe what this Terraform thing is doing. It's basically going to create an instance on AWS on a particular which is going to be deployed in a particular VPC with a security group and all that. So I understand you might not be able to understand it, but I'll make a different video which will kind of walk through this. But I will upload this video. I'll upload the code for this on my GitHub. This is not going to do anything fancy. It's just going to create this thing, an EC2 instance, which we're going to use further, right? I mean, Terraform is cool. I rarely use the EC2 instance, the cloud Amazon dashboard. I barely use it because Terraform just rocks. More videos coming on that, by the way. All right, let me go ahead and run this Terraform and expect it to create an EC2 instance. It is going to do a bunch of things, but let me just run and walk you guys through what it does. Okay, I'm in the wrong folder, by the way. So let me go to this demo. All right. Now I can do Terraform apply, and it is going to do some things basically. If you're aware of Terraform, I think you'll understand it. If not, it's okay. I'll anyway explain that. All right, so it has created an execution plan, and we can see that it is going to create a box EC2 instance which we wanted with all these configurations. It is going to create a EBS block device and a bunch of other things. This is my public key, which is going to add to the box so that I can log into it. Apart from that, it creates a whole lot of other things which I am not going to talk about right now. But feel free to go through the code and ask me questions if you have doubts. I'm going to say yes to this so that it just finishes, it just starts up and does its stuff. By the way, this might take a while to run, so I'll just pause the video and keep unpausing it and talking to you guys in the middle. So while it is creating the resources, let me show you my AWS console. Um, I think it has already created the VPC by now. Yes, it just created this demo VPC. This was a default VPC which was part of my subscription. This created a new VPC. It might be creating the new instance as well. Let's just check it out. It has basically done. So it has created the instance also. Let's go and check out our dashboard. So let me go to my services. And yeah, you can see there's a running instance. As of now, I think, okay, the instance has started as well, which is pretty cool. I mean, Amazon just rocks. It just takes so much lesser time these days to turn on. Well, great job, Amazon. Let me just copy the public URL and ensure that I'm able to log into the box. All right, I took the public IP, and I think the username for that image that I used is Ubuntu. So that, all right, we're not able to log in. No issues. I think I know I made a mistake. So let me go ahead and correct it. Problem is that in my Terraform, I have not specified the security group settings properly, which is why I have to go and whitelist port 22, which is not a big deal. Let's just do that. This is the instance. Let's go to security groups, and add an inbound rule here. So inbound rule right now only allows traffic coming from the same security group. So no external traffic is allowed. Let me just change that. I should have done it from Terraform, but forgive me for that. I did not. Let me just fix it anyway. So let's just quickly search SSH. Done. I am going to accept it from anywhere for the sake of time and save rules. Done. Now let me go back to my terminal again and do it again. And we are in. So we are inside our EC2 instance. All right, so for this demo, I'm going to use Nextcloud. So I'm going to basically install Nextcloud on my EC2 instance, and I'm going to ship the log that generates to CloudWatch. If you don't know about Nextcloud, it's an amazing utility which you can make to use something similar to Google Drive. To keep things short, I have written an Ansible playbook to get everything set up. Let me quickly walk you guys through that. I understand that some of you might not be aware of what Ansible is, but it just lets you manage the configuration of your servers using code. For instance, to install Nextcloud, I would have maybe a bash script written and I would have run that. But in this scenario, I have kind of defined everything in a YAML file, like an overview of what I need to do. So I have to run some common tasks, which are for bookkeeping and all. Then I have to install NTP and then Docker and then JWilder, which is an Nginx proxy. And then at the end, I'm going to install Nextcloud. Don't worry about what and all is getting installed here and all. The most important part is that at the end, Nextcloud is getting installed. Also, don't worry about how Nextcloud is going to get installed, because that is completely irrelevant. I just wanted to show you guys, how this can be done. All right, now that we are through the basic introduction of Ansible, let me go ahead and run the playbook. So I'll let it execute. It will very quickly get over because I've already executed it and the box is set up already. Usually, if you're running it for the first time, it might take around 2 to 3 minutes to finish. Awesome. So Ansible has finished and everything is set up. Just to verify, let's go to our box and see what is running in it. You can say Nextcloud is running, and so is JWilder and MariaDB. So Nextcloud is essentially using MariaDB as a database, and this is like an Nginx proxy, which is going to reverse proxy the traffic to Nextcloud. Now, let me change my host file with public IP of my EC2 instance. Basically, I want the traffic to go to my EC instance whenever I type drive.takemetoprod.com. In real life, I'll have to do this on a DNS provider, but for the demo purpose, etc host just works. Just to make sure our changes have gone through, let's just verify it, and yes, our changes are there. Awesome. So if I go to drive.takemetопроd.com, I should be able to see my Nextcloud setup. All right. So let's go to drive.takemetопроd.com. And there you go. It's showing me the login screen. Cool. Let me again log into my server. And I want to show you guys the logs basically. So my logs are located in cd opt xcloud and I believe data. Yes. And let me do just sudo tailf because that requires root permissions anyways. Don't bother about that. Right. So you can see some logs here. Let me just enter and you can see that, you know, we are seeing new log lines coming up just to validate that. Right. So that means whenever you access something here, it's generating a log event here. Now, these logs are in this particular directory, and I want to ship these to CloudWatch so that I can, query on them. Not that I can't use a good old grep here, but it's a good idea to aggregate logs in a single place when you have a bunch of servers running. Now, you cannot just directly start sending logs from your EC2 instance to CloudWatch. First of all, you have to sort of give a permission, basically allow that your EC2 instance can send logs to a AWS service. And as you know, access to any AWS resource can be controlled using IAM roles and policies only. So I find this part extremely boring, but we have to do that. So you have to essentially create a role basically. And on that role, you have to sort of, attach that role to your EC2 instance, and that will kind of give it authorization to start sending logs to your CloudWatch service. I know it's pretty straightforward actually. So the idea is pretty simple, right? You create a role and you attach it to your EC2 instance, and that sort of gives it a permission that okay, I can now send logs to CloudWatch. If you do not attach this role, then if it tries to send logs, it will get access denied sort of thing. So how do we create a role? We log on to our console. At the end, I'm going to actually do it with Terraform because creating a role with the AWS console can be extremely boring and repetitive. But anyway, I understand you guys might still want to see that, so let's go ahead. If you want to skip this section through, you can. So the console is here. You can go to services, IAM, and then roles. Click on create role to start creating a new role. In here now you pick AWS service, and they kind of provide you a template to create things easily. So common use case is EC2. That's what you want to this related to your EC2. So here also select EC2, and then they'll ask about your use case. Pick the first one. It says allows EC2 instances to call AWS services on your behalf. So this is exactly what we want, right? We want our EC2 instance to call our CloudWatch service to do something, basically to store logs. All right, next. Now in this, you have to pick a policy related to CloudWatch. The policy name is cloudwatch-agent server policy. Once you select that policy, click next. Should be done. You have to pick a name for that. CloudWatch logs. That already exists because I have already done this demo and I've created that role. But just to continue, let me pick a new one. And once you do that, the role is created. Now, the role is created. How do you attach it to your EC2 instance, right? So for that, again, go to your services, EC2, running instances. Oops, I'm in the wrong data center. So I am in actually Mumbai. That's where my server is. All right, now I can see my server. Here it is. So you can go to actions. Actually, you can click on this and you go to actions. You can go to instance settings, and then you can say modify IAM role, and then you can go ahead and pick your CloudWatch logs from here. Extremely painful, I understand, and that's why I have Terraform. So whatever we did as part of the console thing is actually available here. This does the exact same thing. It creates an IAM role and it creates an attachment with the policy. It attaches the role with the policy first, then it sort of creates a profile which you can attach to your instance. Here's a subtle difference here, but then that is irrelevant. And once you have this profile created here, you can go to your instances and specify a IAM instance profile. All right, all that has been said and done for me. So let me go to the box and configure agent on that. So first of all, you have to set up the CloudWatch agent. Let's do that. So you have to download CloudWatch agent. This will take a few seconds. Once it's done, actually, you can install it using dpkgi and cloudwatch.deb. But this might not work for you if you're not using Ubuntu. I'm using Ubuntu AMI here. If you're using something else, you can just search how to install CloudWatch agent and you'll get a lot of docs on that from AWS. Once you run this command, installation would be done. So let's move on. I'm actually not going to run this command because I have already run it. Now let's go to and this is where our configuration lives. Here you have to create a file config.json. File name is irrelevant. You can create a file with any name, just that it has to end with .json. It has to be a JSON file. Let's see what's inside it. Basically, here we are specifying that CloudWatch agent should collect logs from this location, and it should be stored in a log group called nextcloud.log. Well, log group comes in handy if you're collecting logs for similar things from multiple servers. Log stream name kind of uniquely identifies your log line. For instance, if you have Nextcloud running on 10 servers and you want to identify which server did the log come from, then log stream name comes in handy. Well, personally, I prefer using local host name here, and some people prefer instance ID. Again, that depends on your architecture. Awesome. So the config is added. Let's restart the agent for the configuration to get reflected. Restart, and that's pretty much it. Now let's look at the status of the agent once. You can see that it was started around 11 seconds ago and it's working fine. So this should start shipping logs to CloudWatch. Let's quickly go to our console and verify that. We have to go to CloudWatch, log groups, nextcloud.log. And as you can see, log stream is this. This was basically the host name of my EC2 instance. And if I click on this, then I can see all the logs, right? Now the thing about CloudWatch is that it identifies what kind of log it is and it kind of beautifies it. So it has identified it's a JSON log line and it has kind of beautified it for you. Not just the beautification part, it provides you a very powerful interface to search things, which we will cover in other videos. Also, I'm going to make the alerting part that I talked about here. And I'll also talk about the querying part where you can analyze the logs you store here and take some meaningful actions. I hope this video was helpful for you guys. I'm going to come with a better video very soon. Thanks for watching.